Now in this lesson we look at proving results. Examples. Firstly, we need to show that the triangle with vertices A, 1, 2, B, 4, 1 and C, 3, 8 is right angled. Now there are our 3 points. We will draw a quick sketch marking in that information. Now the sketch doesn't have to be super good, it just requires a little bit of work on the scale though, such that they are roughly in the right position. The triangle is drawn, and if we're trying to show that it's right angled, have a look at the diagram. It would appear that this is the angle that might be the right angle. So we'll try to look at trying to prove that there's a right angle there. In other words, that the line AC and the line AB are perpendicular. So that's what we're going to try to prove, that AC is perpendicular to AB. Now, as soon as we start talking about perpendicular lines, hopefully you can remember we should be thinking gradient. So the gradient of AC, let's have a look, and the gradient of AB. So those two we're going to try to work out, and let's see what happens. The gradient AC firstly. There's our line AC highlighted. We look at the y values and we subtract. So 8 minus 2, and they are over the x values, the difference, 3 minus 1. And 8 minus 2 over 3 minus 1 works out to be 3. Okay, on the top have a look, 8 minus 2, that's 6. On the bottom, 3 minus 1 is 2. And 6 divided by 2, of course, is 3. Now what about the gradient AB? Well, if we look at the line there, we look at our y values and we subtract. So we get 2 minus 1. We do the same for our x values. We're going to get 1 minus 4. And when we calculate that, we work out to be negative 1/3. Now, looking at the two gradients, terrific. One is the negative reciprocal of the other, so they are perpendicular. But in terms of showing it, we will say this, that when we multiply MAC times MAB, okay, that multiplying the two gradients, we get 3 times negative 1/3, and that works out to be minus 1. So if the product of the gradients is negative 1, we can say AC is perpendicular to AB. Therefore, triangle ABC is right angled at A. Excellent, we've shown that first part. The second part, hence, find the area of the triangle. Well, because it is a triangle, write down area equals a half the base times the height. We're dealing with a right angled triangle, so we can use that formula. We need to know, though, the base length and the height, alright? So we don't know that information yet. So because we're dealing with lengths, we're going to say that AB equals big square root, the distance formula, okay? We take our x's there, 1 minus 4, don't forget to square it. Then we add, and we look at our y values, 2 and 1. We subtract 2 minus 1, and we square that as well. And when we work that out very carefully, leave the square root till at the end, look what's under the square root sign. We work that out, works out to be 10 under the square root sign, and because it doesn't work out nicely, we'll leave it as the square root of 10. Mark it in on the diagram, very useful. At this stage now, we better look at AC, that length there. So AC equals, same method, using the distance formula. Let's look at our x values, 3 and 1. So 3 minus 1, we square that. Then we add, looking at the y values now, 8 and 2. So 8 minus 2, we square that. Again, looking under the square root sign, let's calculate that. It works out to be 40, so it is the square root of 40. Just about there. We've got root 40 as the height. So now we can work out the area of the triangle. Here we go. Area equals half base times height. So where the base is root 10 and the height is root 40. So a half times root 10 times root 40. We put our half down. Root 10 times root 40 is the square root of 400. Now half of that, the square root of 400 is in fact 20. So a half of 20 is 10. And because we're dealing with area, we write 10 units squared. Excellent. Well, that concludes our lesson. If you get stuck on some of these questions, have a look at the worked solutions, and that will be a very useful resource in showing you what some of the steps required are.